So beginning a new sketch, once again I made a project, I saved it, so I am ready to go. Remember, we first always want to begin, put in a couple comments at the beginning, name, date, and subject, or what it's going to be about. It's a good practice to get into. Now I have my standard two functions. We have setup. So we started out with the word void, two parentheses, open curly brace, return twice, close curly, up arrow once. Then we can put stuff in it like size. And now with that, I'll do my standard 800 by 600. Now, if I auto format that, remember under edit, auto format, Command or Control T, that puts in the extra space, lines everything up, looks all nice and pretty. So we're in good shape. Now I have my second function, so I'll return twice, void. And the reason we use the word void there is, well, one, it's required, but two is inside of processing, like many other languages, functions have an opportunity to return something to us. So they're a utility function. We give them something or we ask them, they give us something back. They return a value. But some functions just do. They don't return anything. And that's why we use the word void. Void meaning empty or nothing. It doesn't give us anything, it just runs. So with this, what I want to do is I want to draw a ball on screen, and I want to make this ball move. So if we remember from our previous exercises, I'm going to put in a stroke weight of 4 just so I can see it a little bit better. And now I'm going to put in a stroke color. Now what color? Once again, I will use my color selector to choose a color. Heck, why not? It's remembering I did purple on my last go, so copy that, paste it in, semicolon because it's the end of a line. And now I will choose a fill color, and as I put in a fill color here, copy that, paste, close parenthesis, semicolon, and now once again we can use ellipse, and now I get to specify where I want to see this. So first we're just going to put it on screen somewhere just so we can see it. We'll just put it at 100, 100, and I will make this 50 by 50. So it's a ball. Now let's run our sketch and see what it looks like, and we can see there it is on screen. Now this background color, we'll take care of that in a little bit. We want to do something first so then we can see why we want to color that background something else. So currently though, I've just drawn this at an empirical part. It's fixed, I can't change it. But if I have values that I want to be able to update or change or work with, those values inside of programming are called variables. So variables are a way that we can store a value that we want to be able to update or change. So to do that, we have to instantiate or give those variables a value, and then we can update those variables later on. So before my setup, this is where I list my variables. So I'll just put a comment, variables here. And variables need, in processing, we have to specify what the variable is. So if it's going to be a whole number or an integer, I use int as the type. If it's going to be a value that could have a decimal point, so like 3.456, then that would be a float because we're referring to those floating point values, the things after that decimal point. So if I just want to draw this with integers, which is just an easy way to get started, what I can do is just type int, and I want to store a value for my x, and then semicolon. Now I want to store a value for my y. So these are where it's going to be drawn on screen. Now we need to give those starting values. Now processing is, again, it's been designed to be user friendly. So some programming languages are very kind of computer focused so that They work well with the computer, but they are not very nice to the people writing code. Some languages are designed to be nicer to the people writing code. Processing is one of those. So if you don't give your variables a value when you begin, they start out at 0. So let's give these values. So I'll start out and say x is going to be equal to, now I'm going to put in 0 here, and I'll say y is going to be equal to 0. And I'm doing that for a reason, just to reinforce that our ellipse draws from its center. So now this time, instead of drawing the ellipse at 100, I'm going to draw it at x and y. Auto format that so it cleans it up. Command or Control T. Now let's rerun our sketch, and we'll see that there's our circle off screen. So if I don't want it to start off screen, I need to give this a bigger number. I'll begin with setting x, at this case, to 25, not 250, 25, and I'm going to put my y value down to height. Remember that if we specify height and width, we're referencing the values that we have specified in our setup. So now if I run this again, we should see the circle is over here in the middle of our sketch. So this is just the starting value. Now, one thing that we could do with this, I'll put in a comment in there for what that is, and now I'm going to put in some white space. If you remember, it was mentioned that setup runs once, draw runs about 60 times a second. So if we take x and we change its value over time, so we say x is going to be equal to the current value of x, but let's just add 1 to it. And I just put a space there so it just looks clean. Auto format, sometimes when you have the pluses right up against numbers, it doesn't always auto format that quite the same. Now if I run my sketch, you will see that that ball is moving. Well, also notice that it's drawing over the top. Let's just switch this and we'll say let's go 10 and run it just so we can better see it. And you can see how the balls move 10 each time. We can see where the stroke is, where the previous balls were drawn. So that's cool, it moved, but it's problematic because as it's moving on screen, we're seeing all of the previous ones. I mean, maybe sometimes we want that. But an easy fix for this is we can clear the background, and we can do that just with the simple background command. Now if I want to fill it with the same gray color that's there, we figured out that was approximately 200 on the gray. Now if I run this, you'll see that there is the ball moving across the screen. It disappears because it's now continuing, it's still going. That ball is still going. Now if I want my background to be a color, so if I wanted it to be like the cyan color and put that in, paste that in. Now let's run it. And we can see it moves. All right, that's a little hard to look at. It's kind of too bright, so I'll choose a different color. Oh, we don't want 2 of those hashtags. There, that's better. So the ball is moving across the screen. Now we can go back and make it move a little bit slower. And you can see how it's moving. Now there's a general kind of concept when we're doing visual programming, game programming, and things like that. Anytime we're designating something to have a numerical value, is that we set a variable to hold it. So this amount that we're changing our x by, that's really kind of a speed value. This height and width, those are size values as well. So if I went int, not hint, int, w for the width, int h for the height, and speed x. So let's add in some extra values here. Now let's set those so that I go w is going to be equal to, if we keep it the same, I'll just say 50. Now if I didn't want this to be a round ball but to be oblong, maybe I could say it would be 70 high. Now if I change this 50 right here to w, this 50 to h, and run it, we'll see our program still works. Now the nice part is our values, they're all defined up here. So if I want to change something, I don't have to go look through my code to go and find it. So let's go speed x is going to be equal to 2. Just want to go a little faster. That one's pretty pokey. Speed x. Now if I want it to be a ball again, well, I can just change that up here. So knowing all our values are in one place makes it much easier to maintain and update our code. Now, so it still looks the same, but you'll notice we have more control over what we're doing. So we're able to move it, we can animate it, it's going across the screen, so it's doing everything that we want it to do, except it's disappearing. So we'll take a look at that next. To combat the ball going off screen, what we need to have happen is we need to find a way to check for that and then reverse direction when that occurs. And this is where it's going to be useful that speedx is contained inside a variable. So I'll put in a comment for what I'm doing next. This is going to be my boundary check. So what we can do is we can write it out in plain language, and then we'll kind of put this into code. So we're writing in what's called pseudocode. So I'm just going to write it out. It's going to give me all kinds of error messages, and then I'll figure out how to write it in the code. So if x is greater than width, then speed x needs to reverse. So instead of adding to our x position, we need to take away from it or subtract. All right, so just comment out that pseudocode, and now it was highlighted. Now let's go here. So the way that we do it is we write the word if. Notice it turned green. Now I'm going to have parentheses, and I'm going to say if whatever is inside those parentheses is true, then we'll have a curly brace, return arrow, close curly brace. Let's go back up. So remember, so if x is greater than the width, so now we write that in code, so we can say x is greater than width. Now the nice part about using the word width here versus putting in the number 800 is if I change the size of my sketch, my code still works, it doesn't break. So if it's greater than the width, then what we want is we want our speed to reverse. Well, speed is currently a positive number, so we need to reverse it. So we could say speed x is now equal to -2, but there's kind of a better way of writing it. And we would go speed x is equal to speed x times -1. If we multiply a number by -1, it changes its kind of polarity. It goes from positive to a negative. Oh, I need a semicolon to close out the line. So if my x is greater than the width, speed x is going to be equal to speed x times -1. So it will go from +2 to -2. So we're going to change the speed up a little bit just so it happens faster. I'm going to change my speed to 5. Now the nice part is I changed the number here. All of these other instances of speed x will reflect that. So it goes across, And you can see now it goes, oh, we ran into another problem, and that we now went all the way to the left. So that's a problem. So what we could do is we could write another if statement. We could also just continue this on and say else if, or we can just write another if. In this case, it's probably going to be just fine to write as two separate ifs, because we can't be on the left or right edge simultaneously. So we could do an else if, or we could just start out with a whole new if statement. Else if x is less than 0, curly brace, return twice, close curly brace, up arrow once, speed x is equal to speed x times -1, semicolon, to punctuate that sentence. So now that we have this, auto format, save, because I've done a lot of work and haven't saved yet. Now let's run this and see what happens. Goes across, now it's going back, going across, and you'll notice it gets halfway off screen and then it reverses. If we change our speed back to 1, it'll be easier to see that. It's going to take a little longer to get there. But what we're going to see is it moves until the center point, until x. See, it gets halfway off and then it goes all the way, and then it will go until that center point, because remember we're drawing from the center. So what we want to do is we want to modify this a little bit. So it's not, so if our x, and we can add to either side of our kind of equation here. But it's if this situation, if x is greater than width, is true, then it does what follows in the curly braces. That's how a conditional statement, that is our programming term here, it's a conditional. That's how that works. So what we really want is if x plus half of our width here, because that would give us that right edge. And I'm going to just start out my x in the middle just to speed things up. Let's run this again. So now we start at the middle. And now what we should see is when it gets to the edge of the screen, it bounces. But we didn't change the one down here, so if x, but this one, we want left of x. So x is in the middle of it, and we want to be kind of to the side. So what I'm going to do on my ball here is I am going to just draw a little dot right in the middle. I'm just going to do fill with red, stroke away back to 1, and we'll draw at x and y, but this time we'll just do just a tiny little dot. Let's see if that's big enough. I might have to go a little bigger. Okay, it's there, but it's really, really tiny. All right, let's go 4. You can see there's a little, okay, the red doesn't show. Let's go yellow. I forgot we're on purple. There we go. So now we can see a little dot. So we can see when that dot, that middle part, hits, well, there we already fixed this one, but when we get to the left edge, we're going to notice we move all the way to that dot. So we want a value less than that dot, because it's moving, 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 boom. So a value less than that would be, we subtract half of the width. Instead of adding half of the width of the circle, we're now subtracting half of the width of the circle. All right, so now let's run it again. And we should see where it bounces its edge. I should have made the whole sketch skinnier so we don't have to wait quite as long. You will notice some of the stroke is going off screen because of how it draws the stroke. So as it puts the stroke around that object, but we can see now it's primarily contained. And if our speed is more than 1, it pretty much is hitting the screen and we can't tell that any pixels. So if we care about absolute pixel perfection, then we will have to change our numbers a little bit just based on the stroke width. But for now, which we could store that as a variable, and then we could work with that in our code. But in the meantime, we're not going to. So you can see I even added, additional things. I added this little extra circle. So if I wanted to, on my circle here, add in eyeballs or something, I could draw additional elements. I just have to offset them. If I don't want it to be centered, if I wanted to draw another ellipse, but if I move it over 10, and if I move it up 10, you'll see that now I have a circle up there, kind of up and left of center. I wanted a second circle, this time do plus 10. You'll notice what I'm effectively doing is I've just put eyes and a nose on my little circle here. So we're offsetting relative to the origin point. So always think of like our object here. It has an origin point. That origin point is the X and Y. And we're drawing everything in relation to that. So now we have it bouncing off the two sides. So we've created an object, we've added additional elements to it, and it's animating. And it's continuing to animate on screen. Now there are other ways that we could animate it. Instead of having it bounce, we could make it do screen wrapping. So when it gets to the right, it automatically resumes on the left side, so it just keeps looping the screen. That would be another way to do it. So there's a lot of possibilities to grow and expand this simple example that we've created. So good luck and have fun coding.